Alright, welcome back, ladies and gentlemen. This is a lesson on limiting reagent or limiting reactant. It's the same thing, reagent. You'll see this term interchangeably. Okay, so this is a loaded lesson. Okay, it's a lot of material on here. This is probably the most confusing or most detailed lesson that you'll see this year in chemistry. So let's just get started here. Limiting reactant means the reactant that runs out first in a chemical reaction. The reactant that runs out first. What does that mean, it runs out first? What does it limit? Why is it limiting? What is limiting? What is this reactant limiting if you run out, right? If you run out of it, this reactant, then it stops any more product from being produced. It stops any more product from being produced. So it stops the reaction. It limits the product. So it limits the product. So that's why it's called a limiting reactant. It limits the reaction from going forward. For example, if you make sandwiches, you run out of bread, that means you cannot make any more bread. The bread is a limiting reagent. The bread is a limiting ingredient. Okay. So how do we do that? Okay. So you're always given two ingredients, right? So two ingredients, for example, here you have 10 moles of BF3. You look at this equation, BF3 and 2.25 moles of H2. There are multiple ways of doing this, but I will show you one way. So you'll find out in future chemistry classes that there are other ways of doing this, but follow this way. So you have to set up two grids, 0.1 mole of BF3 and then 0.25 moles of H2. And then you choose whichever product you want to get to. Okay, is it boron or HF? Boron looks easier, but if you look ahead of time, hey, look, we need to find the mass of HF later on here on B, so let's go to HF. All right, so we want to figure out how much HF can be produced. All right, since we need to go to grams of HF on part B, let's go all the way to grams of HF. Set both of them to go to grams of HF. Okay, so moles. Remember, it's mole, and then we can go to mole of HF. We can go to mole of HF, and then we can go to grams of HF. Grams of HF. Grams of HF. Okay. So mole, grams, the same order that we've always done. So copy the unit down here. 1 mole of BF3, mole of H2, mole of HF, mole of HF. Alright. So just applying the things that we've learned. Mole over mole, look at the equation, which is mole over mole, HF is 6. Same for both grid here. But the bottom, BF is 2, H2 is 3. So we get all these numbers from the coefficients here. 2 for hydrogen is 3. For boron fluoride is boron trifluoride. I think that's where it is. And then HF, mole and gram, 1 mole. Find the mass of HF. Fluorine is, get a periodic table real quick. Fluorine, the mass is 19 and H is 1, so then both is 20. Right, 19 plus 1, hydrogen is 20. And so then now you have your grid here. Again, I'm going through this fairly fast because we've done enough of this already. Remember, this cancels out. I've got an L there, but this cancels out. This cancels out with the bottom. Top, bottom cancel out, and we're both left with grams of HF. So we'll calculate those with a calculator. 0.1 times 6 times 20 divided by 2. And so that gives us 6 grams of HF. All right, 0.25 times 6 times 20 divided by 3, and that'll give us 10 grams of HF. Oops, got the H there. Okay, I think I did that right. 2, yeah, 3, 6, yeah, this looks good. All right, so let's answer So which one's the limiting reactant? So the one that creates the least, makes the least amount of product is the limiting reactant. So is the reactant, right? The starting material that makes the least is the limiting reactant. So which one of these two? Which one? BF? Which one of these two? BF or H2? Which one produced least? It would be BF. So your limiting reactant is your BF. Boron, fluoride. Let me see. I'm trying to get different colors here. So boron, that is your limiting reactant. Okay? And so it says B here, what is the maximum amount of grams of HF produced? So the amount that produced is 6. We don't have enough BF to make 10 grams of the bottom one. Okay? So it'll be just 6 grams of HF here. That is the most that we can make. The lesser is the answer. The starting material is the limiting reactant. Okay, so we set up 2 to see which one makes the least, and the one that makes the least amount is your limiting reactant. Okay, that should help you do number 2 here. You should be able to do number 2. I'll get you started on number 2 here. We have a combustion of ethane here. You have 1.45 grams of C2H6. So if they give you 2 starting material, you have to set up 2 grid, 4.50 grams of O2. Grams. Say what mass of CO2 is produced. So we need that CO2. We need to set them both to go to grams of CO2. So grams C2H6, we go to mole of C2H6. Then we go to mole of CO2. Then we go to grams of CO2. A lot of work, yes. Mole of O2, right? O2. And then the second step, the second part of it, both of them are the same because both of them going to CO2. All right. Should be pretty good at this now, pretty fast at this. Grams of C2H6. Grams of O2 down here. All right, bring it down. Oh, let's finish one at a time so we don't confuse ourselves here. Here's the mole of CO2. Mole of O2 goes down here. Mole of CO2. We've done this enough so that I don't have to show you again. Remember that we keep bringing the unit down, keep bringing the unit down. That's really what we've been doing. Fill in these numbers. Grams over mole, 1 mole, 1 mole. Get those numbers right. Grams over mole again, the last step, 1 mole, 1 mole. Mole over mole, get it from the equation, 4 CO2, 2 C2H6. Mole over mole, 1, 4 CO2, O2 is 7 O2. Okay, now I get the grams. The mass of C2 is 24 here, 12, 24 plus 6, that's 30. Mass of O2 is 32. We're just filling in these tables. O2 is 32 plus 12 is 44. Same thing here. The last 2 steps are the same. Just copy these part. Okay, the last grid here. So we get our calculator. Remember, all these units cancel out except for the last one that's left up there. Top and bottom cancel. Okay, good. So I calculate this thing, 1.45 times 4 times 44 divided by 30 divided by 2 on top, and I get 4.25 grams of CO2 on top. 4.50 times 4 times 44 divided by 32 divided by 7, and I get 3.54 grams of CO2. So now you say which one produces less? It's going to be this one. The bottom one produces the lesser amount. So the limiting reactant is the starting material, is O2. So to answer that question, the limiting reactant is O2. It runs out first. The material. Which material runs out first? And so which one's excess? If you run out O2, you have 2 reactants, O2 and C2H6. So the excess is your ethane, which is C2H6. Okay. How much? Ooh, how much? Now this is the confusing part. How much excess? So in order to know how much excess, you have to know what? To know excess, to get excess, you must figure out, calculate how much is used, right? So I have this much. I have 1.45. You have this much. You have that much. how much is used. How do we figure that out? So this is a higher level thinking here. This is a higher level process here in chemistry. So you know that we produce. So this is challenging. You know we produce that much, so we start with that. 3.54 grams of CO2. We need to figure out how many grams of C2H6 is used. Right? This is used. How much is used, and then when we subtract it from our starting, from what we have, we'll get it. So grams of CO2, moles of CO2, another grid along this over and over again, and then mole of C2H6. Get the units down here, mole of CO2. The nice thing is that you already have all the numbers. You don't have to do any more of this calculation. It's just a lot of tedious setting up here. All right. See, mole over mole. Now we're seeing C2H6. That is 2. Mole of O2 is 7. Oh, CO2. Oopsie, 4. 4. Mole of CO2 1, and we already figured out CO2 is 44 grams from up here. And then mole of C2H6 is 30 grams right there. See? So we have all our numbers. It's pretty nice and sweet. Remember, units cancel out, grams cancel out, mole cancel out, and we're left with grams of C2H6. Then we type that into a calculator. I'm going through this fairly fast, so if you need help, replay it, slow it down. So I get 1.2. See? 3.5 times 2 times 30 divided by 44 divided by 4. So I get 1.21 grams of C2H6 used. Right? So if we have this much, and we have that much oxygen, we won't have any extra. But because we only use that much, that's not the answer though. Right? So we have to take, we have 1.45 and we used 1.21, so we subtract that and we'll get our answer of excess. So excess is 0.24 grams excess, 0.24 grams excess of C2H6 excess. And that's how you do that. With the excess, it does take an additional step. That doesn't go with the grid, okay? I just ran out of space. So that is how you do that one. Alright? And there's more. There's going to be more for you to practice here. So I'll get you started on this and you can be on your own. So we have 2 starting material. Now we're dealing with propane and we're dealing with oxygen. So 14.8 grams of C3H8 and then 3.44 grams of O2. Determine the limiting reagent. And if you read ahead of time, you can see we're looking for grams of H2O here later. We're looking for moles of carbon dioxide here later. So you can go to either one. So let's go to grams of H2O. Okay. So grams of C3H8, moles of C3H8, mole. Remember grams, mole. And then mole again, but then we switch to the other one, which is water. And then grams of water. Same thing here. Mole of O2. Mole of H2O. And grams of H2O. Copy the units down. Grams of C3H8. Write small here because you'll run out of space if you write big. C3H8. Mole of H2O. Remember, copy the unit down. Grams of O2. Mole of O2. And then mole of H2O. Remember, you'll get 2 answers. And the lowest one, the lowest answer is going to answer that question, part C here. The lowest answer, okay? So the lower of the 2. The lower of 2 will answer that question. And the starting material will be your limiting reagent. That'll answer that. So the one that gives you the lower one will be the limiting reagent. Okay? And then to determine the moles of carbon dioxide, you can use the lower of the 2 and determine that. And start with that and determine the moles of carbon dioxide produced. Okay? It is difficult. It is a lot of thinking. You have to understand. You have to actually truly understand this to grasp the concept of limiting excess. So I hope you got it. If you don't, rewatch it. Ask for help. Okay, thank you.